Today's lesson is all about specific type of angles and their relationships, and then how to find measures of them and how to compare them, equal or supplementary or whatever the words are. On Friday, we mentioned the word complementary. Remember, complementary is two angles together that make a right angle, 90, and supplementary two that make a 180, a line. Okay, so the first word today is adjacent. Adjacent means next to, side by side, so close that they even share a ray. So two angles that are adjacent have a ray in common. Adjacent, that works for just about anything. You can have adjacent figures where you have a square with a triangle adjacent, meaning one side of the triangle is also part of the square. So adjacent is just that close. Okay, adjacent angles, that's there's really no comparison other than they share that one side length. There's not like a set of equal or anything like that. Moving on, these are all examples of adjacent. So the 35 degree is adjacent to the 55, the 80 is adjacent to the 45, and you see the colored rays, so that just shows you that they're sharing their ray. And these are not adjacent, so the word would be non-adjacent to non-adjacent angles. That's the opposite of adjacent. These are very close, but not sharing a common ray. So if you have boyfriend, girlfriend walking down the hallways of school, you want to walk non-adjacent. There needs to be space between you. You're not so close that you're sharing a common arm. All right. These, the 35 degrees, they do share a vertex point, but they have a different name. They don't have a ray in common. So this ray is not part of this angle. This ray is not part of this angle. So those are not adjacent. They are non-adjacent. And then even the 45 and the 55 right here, to make the 55, it's these two rays. To make the 45 are these two rays, and they do not share a ray. So even though they share a vertex, they are non-adjacent. All right. Okay, so the next term was vertical angles. Vertical angles make a V, vertical. I have a chant for it. Okay, so vertical angles would be this one, and then they share a common vertex. So the vertical angles are 75, and the vertical angles are always going to be congruent. You guys know, have you ever seen a scissor lift? You know, one of those things that there's a platform here, and if you need to go up high to change lights in a big building or something, they like at Walmart even, I think they have the scissor lift that does this. As that scissor lift is going up, the angles across here and here are always going to be the same. So vertical angle opposite each other will always be congruent angles. They're always made from two lines. You can have vertical angles with among multiple lines, and I'll show you an example in a second, but they are made from two lines only. They share a vertex, they intersect from two lines. I didn't change the screen, there we go. So the BAMs just show you where the vertical angles are. The 75 are there, the 105s are there. They're always opposite one another, and they're always congruent. Matter of fact, you might even write in your box. You're not box in. Vertical angles. Always. Very seldom do we use the word always, but I would box that in. We use that forever and ever and ever throughout all of geometry. Okay. So let me show you an example of more than two lines intersecting. Let's say we have three lines, and then even there's another line coming there. That would be kind of crazy as far as a traffic intersection, but it is possible to have several lines crossing. So they all have a common vertex. But if I shade this angle, it is created from these two lines. So the vertical angle would have to be here. Okay? Even though this has a common vertex, it's still not vertical. They have to come from the same two lines. If I wanted to know the vertical angle to this angle, it's not just this much. Remember, vertical angles, first of all, have to be equal, congruent, and they have to come from the same two lines. So if I were to change my color, that line and that line continue here and here, which means my vertical angle would have to be between the two yellow. Okay, so you, even with several lines, you can have vertical angles. You just have to watch the two lines that create them. Vertical angles, we talked about that, always congruent. Supplementary, we discussed the other day. Supplementary angles are totaling what? 180. Supplementary angles can be adjacent or they can be non-adjacent. So here is a pair of supplementary, 120 plus 60 is 180, but they are sharing a common ray, therefore they are adjacent and supplementary. This set, non-adjacent and supplementary, they still add to 180. Okay, the word linear pair, did I have y'all copy that?
Yes, ma'am.
Okay, so think about that. Tyson, what's a pair mean?
Two.
Two, like a pair of shoes. Two that make a, what's the root word, Holly?
Line.
Two angles that make a line. So two angles that form a line is the definition of a linear pair. Also, a linear pair will always, please add this, be supplementary. Okay, and add a picture next to a linear pair if you have not already. This is not a linear pair. This is just a straight angle. I had the starting point and moved over to here. It takes two angles. So no matter where the line is drawn, two angles, angle 1 and angle 2 together make a line. They are a linear pair. A linear pair is supplementary. Therefore, a linear pair will always make two angles that are totaling 180 degrees. Okay?
Yes, ma'am.
Okay, complementary angles. Complementary angles can again be adjacent, sharing that common side, or they can be non-adjacent. They just have to total 90. Perpendicular. So we have the word parallel. What does parallel mean?
Next to each other.
And never
Crossing.
crossing, never intersecting. So here's parallel. Well, kind of. Never intersecting. Perpendicular is like its opposite. They do cross, but they have crossed specifically to make right angles. All right, so your two lines, if you'll draw a picture next to it, would look like this, and the perpendicular would be marked with a box in the corner. There is a symbol, there's a symbol for parallel that looks like this, just two little lines, but there's also a symbol for perpendicular. So next to your word, please add your symbol. It's an upside down T. Most of the time in the T there is not a box, but I'm going to draw the box there in the corner representing that that T makes a 90-degree angle every time. So the symbol that's used, something would be written like this. Segment AB perpendicular to segment CD. And the symbol is there so you don't have to write the word. You just automatically know together they join and make a right angle. Actually, they make how many right angles?
4.
4. Because if you start here, all the way around is your 360 cut into those 4 equal parts of 90. Okay, so a perpendicular bisector. Tyson, do you remember what bisector means? What's bi? How many?
2.
So it's something that's cutting.
It's cut in half.
There you go. It's cutting a section into 2 equal parts, cut in half. You got it. So a perpendicular bisector would be like if I had a segment and I wanted to cut that in half and make a right angle, I would have a line that goes straight down through the middle, cutting in half, but also forming a right angle. So just bisector, something could go anywhere through the middle. It could go any direction, but perpendicular specifically has to have right angle and cut in half. Okay, how are we on our vocab?
Good.
Good. Kyle, you doing okay? So let's just kind of go through several examples here. I'm going to have y'all kind of back and forth answering. There's some terms that can go with each of these pictures. So looking back over that vocabulary now. Holly, 120, 60, these two angles, can you name some words that describe this?
They're adjacent.
They are sharing a ray.
They're supplementary.
They are because they total.
And they're a linear pair.
Good. All 3 words. Good. pair of angles that form a line. Okay. Nice job. Tyson, any words that will describe those?
They're non-adjacent.
They are non-adjacent, not sharing a common side. What's their total?
90. They're supplementary.
Other one.
Oh,
And it was from Friday, so look back on the other page.
congruent. Wait, no.
It is a C word.
Complementary.
That's the word we're looking for. Complementary, two angles together that add up to 90.
I just said the wrong word.
All right, how about the two 75-degree angles, Holly?
They're congruent.
They are.
They're vertical.
That's the good word. Congruent and vertical. V, vertical. We're looking for they make a V across from each other. Okay. Good. I think that's all. Oh, and I guess, are they adjacent? Or are they non-adjacent?
They're non-adjacent.
Non-adjacent. They do not share a common ray. They only share a vertex. Okay. Vertical angles will always be non-adjacent. How about this set? Throw it in. Sorry, Tyson, it's just kind of the tricky one. 60 plus 40, what does that equal?
90 is complementary.
But wait, what does 60 plus 40 equal?
100.
So is it either complementary or supplementary? Okay, it's neither one of those. There's only one word that applies.
Non-adjacent.
That's the word. Good. Non-adjacent. Okay, that's the vertical again. I'm gonna come on down here. All right, Holly. Words that apply to the 25 and 65 degree angles.
25 and 65. They're complementary.
They are. Together make 90. So because I know that, then I can put that there. What other words?
They're not congruent. They're adjacent.
They are adjacent. They share a common, right? I think that's all.
Okay. Yeah.
What do I know about the two lines? What's the word that would go there?
Perpendicular bisector. Or just perpendicular?
Just the perpendicular, because this is a line, and you can't cut something in half you don't know the length of. So just perpendicular because they make the right angle. Okay. All right, good. Let's go on. '90 and 50, is there any relationship there? What's their total?
140.
140. So not complementary, not supplementary. Are they adjacent? No, do not share a common side. Come on, Evercrow. So I guess since they're not adjacent, they're otherwise known as non-adjacent. And can these make a linear pair? How many does it take to make a pair? Two, and that's 1, 2, 3. So they do eventually make a line, but it's not a linear pair because there are 3 angles there. All right. Okay. So how could we find the missing angle? Knowing our information, it's all leading up to, you've got to know the vocabulary to work the problems. Missing angle. Tyson. What do I know about these two together?
They equal 180.
Yes, they are a linear pair. And so how would I find this?
Subtract that from 180.
180 minus 45. Do you know it? Anybody?
135.
We did that in our head. Yep. 135. You got it. Okay, how would I find the missing angle here? Now this one is a little tricky because this one I'm going to say we can't do. You may know why.
Because it doesn't tell you that it's 90 degrees.
Exactly. We never want to assume anything. If the mark is here showing that right angle, then you know it's a 90. But without it, you really could not tell for sure. Okay. So let's say then this is a 90. Then what do I do?
Subtract 65 from 90.
And get
25.
25. There it is. Okay, so Kyle, you were kind of doing your quiz during this, but I'm going to show you on a scissor lift as it picks up something. Somebody's on the lift at Walmart going up high. The angles across from each other always stay congruent to one another. So this one
35.
and that one, they would be the same. Those are called vertical angles. They share a vertex. They make a V across from each other. Vertical angles are always congruent. Okay, so 35 is correct. And let me go on to this one. Okay, if we know how to put the numbers in there, we should be able to look at this picture and also put an equation together. That's the main goal, is now you know linear pair, you know adjacent, you know all the terms, but what can we do with this? So together, these are two angles that form a what?
Supplementary.
Supplementary, so together they are a linear pair. They form a line. Supplementary means together they're going to total 180. I didn't really have to tell you that, right? From the picture, we can tell that that's 180. So I know that they will equal 180. Together, meaning what mathematically? Together. So, Tyson, join those together for me. 2x plus 1x.
3x.
And then 50. Okay, I'm going to solve. Y'all solve real quick. Make sure I did my math right. It is a decimal, right?
Oh, yes, ma'am.
Is it 76.6?
Yes, ma'am.
76 and 2/3. Okay. So even though it doesn't come out evenly, we still get our value for x, and we could go back and we could approximately say this angle is nearly 77 degrees, and then we could subtract from 180 or substitute and find this angle also nearly 103 degrees. Okay. For angles, I do like them rounded to the nearest whole number. So in a case like this, you could round up or down.
Yes, ma'am.
Okay, well, that's all of the lesson for today. It's just using those words, figuring out what degrees are, what the angles are representing, and even using your algebra in there. Okay, thank you. Can you